recordings. I'll share my screen. Okay, I hope my screen is visible. Yes. Okay then. Welcome to week 7 of this tutorial session for the joy of computing using Python course. And so I'll be solving some problems. So I'll be giving some questions, and then I'll be solving them myself. But I would like you to also try to solve, at least even if you don't type it yourself. I would like you to at least think about what the solution to the problem can be before I solve. I'll give you 2 minutes to think about it. And anytime if you have any questions, then feel free to just write in the chat. And if I'm asking after I have solved the problem, if I'm asking something, then you can feel free to unmute yourself and ask directly, or you can utilize the chat as well. Okay, then let's start. I hope my screen is visible. Yes. Okay, so let's go on to the first question. So this week we will be again doing some recursion problems, but these are slightly more advanced than what we did last week. So this is a relatively simple recursion problem. So write a recursive function to check if a string is a palindrome. So you know what is a palindrome, I hope. If not, then I'll just explain quickly. I'll just remove this. Question is a palindrome. Okay, I hope it is visible. Okay, so palindrome is basically a sentence which if you just reverse it, then it will be the same as it was originally. So for example, mom, if you reverse mom, then you get mom again. If you do race car, again if you reverse it, it becomes race car. If you do something like I don't know, hello, then if you reverse it, you get something else. So this is not a palindrome. Not palindrome. Okay, so simple to understand. So mom is a palindrome, race car is a palindrome, hello is not a palindrome. So obviously if you want to solve it using loops, that is, it's quite easy, but we want to learn the recursion, the concepts of recursion, so we want to do it without using loops. So for this first problem, I'll probably solve it using both ways. First I'll use loops, and then I will do it using recursion. So so if you have any idea, you can type in the chat how to do it, or you can just start thinking about yourself. How do we check if a string is a palindrome using, say, just loops? So let's say we have a input string. Let's call it s equals to say hello. Why not? Now you want to check if s is a palindrome or not. Let us write a function for it. Let's call it isPalin, and it takes a string as input. We do something, and we return true or false. Like if it is a palindrome, then it returns true, or else it returns false. So we'll write that function. So we take the input, and then we print out say if isPalin, then we print, say, it is a palindrome, else it is not a palindrome. Okay, so simple. So now all we are left with is just to write this function is palindrome. So let's just do it using a simple loops, just using some for loop or while loop. So how shall we do it? So our basic concept is that we want to check if so we can do it in multiple ways. So one way, simple as I explained, so you can just reverse the string, and you can check if the original string is same as the like reverse string. So what when we want to do it using a recursion, we have to do it slightly different way. So that's why we'll do the loops also in a slightly different way. So what we want to check is basically we want to check if the first character, say R of race car, so first character is R and the last character is also R. So we want to check if the first character and the last character is the same. Then we want to check if the second character and the second last character is the same. Then the third character and the third last character if they are the same. So you are checking two sides, and we do that till we reach the middle. So in the middle we will all have either say nothing in the middle, or we will have one character in the middle. So in both ways it will be the same. And if we find that the whole string is matching like this, then we can say this is a palindrome. And if anywhere we see that the nth character and the last nth character does not match, then we can say that this is not a palindrome. Okay, so let's put it in full screen now and let's try to solve it. So let's take a I as 0, and while so we'll go up to say while I is less than, so we want to go till the middle, right? So we'll do less than length s divided by 2. So we want to run this loop till the middle, like I said. So we want to check till the middle, and each time what do we want to check? We want to check if the first character and the last character is same. So basically ith character and the last ith character is the same. So in Python it is really easy to check. We want to check if si equals to s minus I, you can write. So minus I just will mean actually not minus I, minus I minus 1. So yeah, so 0th character and minus 1th character. So this basically means that we are checking ith character and the last ith character basically. And if they are same, then we can't say it's a palindrome. We need to continue checking. But if it is not the same, if these two are not the same, then we can definitely say that this is not a palindrome. So we will return false if they are not the same. And if it is the same, then we keep continue doing this. We check it for all the characters till the middle of the string. And if everywhere else we see that this match has been there, then we return true. It is a palindrome. Okay. So relatively very simple. Let's check if our code is correct. So input is hello. So it just says it is not a palindrome. If we do something else, say race car, then it is stuck somewhere. Oh, okay. So yeah, there is a problem. So we have missed one line. Can anyone tell what is that we have missed? And so the problem when we are running this, it is going into an infinite loop. Basically, it's not ending. So can anyone unmute yourself and tell, or just write in the chat what we are missing or what do we need to add? We are missing just one line. So yeah, debugging code is also a very essential part of programming. So can anyone tell? I'll wait for a couple of minutes.
I equal to I plus 1 should be there somewhere, I think, right?
Yes, exactly. No, it is required. Yes, you are correct. So exactly. So we are looping with I. So we have forgotten, like I forgot to write I equals to I plus 1 or I plus equals to 1. So we have to, after checking for the value, if it is not matching, then we have to obviously increase the value of I, and we continue checking from the next number. So now let's stop this first. Yes. Now let's run it. And it says that it is a palindrome. Yes. So our code works now. So this is basically we are using just one loop to do it. So let's convert this to a recursive function. Okay. So let's give it some other name. Say loop. Let's write another function. Define is palin. So this we'll do using recursion. So here also we want to identify how can we convert this looping action into a function call. So we have to identify what part is repeating. So here it is very easy to figure out that in each step of the loop we are basically checking if the first character of the string and the last character of the string, or like ith character and the last ith character are the same. Okay, so given to convert it to a recursive formula, we can say that we are first checking the first we are checking the first and the last character, then we are removing the first and the last character, and then we are repeating it again, right? So suppose we are checking for race car, then first we check that r and r are same. So now we keep on checking for the rest of it. We remove the first and the last character, and we check if this remaining thing ACCA, this is a palindrome or not. Then we see that A and A are matching. Then we go on to the next step, which is CEC. We check if these are same or not. So this is what we are doing. So we are checking the first and last character. We are removing them, and we are doing this, calling the same function. So I think you can understand. This is our recursive formula. And here also we'll have we'll have a base case. As with all recursive formulas, we'll have a base case where we want to, like, that is the simplest case. When we know the answer, we want to stop there. And the recursive case, which is where we want to recursively call this function again. So the base case for this will be when len of s is less than equals to 1. So if there is only one character, then we know that it is definitely a palindrome. If a character is just say a or b, so that obviously if you reverse it, it is still the same. Or if there is nothing in the string, if it's an empty string, then also it will be a palindrome. So this is our base case. If length of the string is less than equal to 1, then we return true, right? And if it is not, if the length is greater than 1, then we move on to the recursive case. Let me just write it, base case. And the recursive case is basically when we want to call is this function again by itself. So what we need to do before that is we need to check if obviously what we wanted to check is if the first character is not equals to so this is similar like last time. So first character is not equals to the last character. So last character means basically -1. So if it is not equal to, then we can return false, right? And if it is equal, then we can't yet say. We need to check further. We need to just remove these first and last characters, and we need to check again. Then we want to return is palin. We want to remove the first and last characters. So 1, 2, -1. So this means that we are removing the. So we are starting from the first character, and we going till before the last character. So this means we are going till before the last character. So we are just basically removing the first and last characters. So this is our code. And you can see the similarities between like the loop function and the recursive function. So let's just check it once again. Let's just comment it out. We have commented it out. Okay, let's check if it is working correctly. So for race car, it says it is a palindrome. Let's say mom. It is also a palindrome. If we do say moom, it is still a palindrome. But if we do something like moo, then it should not be a palindrome. Okay. So our code works well. So any question on this? So this program or in general about recursion? These are very simple, relatively simple. So this was just a refresher about recursion. Okay, I don't see any messages in the chat. Okay, so let's just move on to the next question. Okay, so now a slightly more challenging problem. So now we want to write a recursive function to print the power set of a given set. So you're given a certain set and you want to print what is the power set. So you know what is a power set, right? Let's go here. So if you are given a set, say 1, 2, 3, 4.
Set of all subsets.
Yes, basically, exactly. Set of all possible subset, all possible combinations, and yeah. So if you are given, say, let's start with a smaller one. So if you have a set of 1, 2, 3, 4, so power set will be a set of containing, say, 1, 2, 3, 4. These will obviously be there, and then we'll also have, say, 1, 2. We'll have 1, 3, 1, 4, and then 1, 2, 3, 1, 2, 4, 1, 3, 4, and then we also have, say, 1, 2, 3, 4 also. Yeah, let's just write it here. 1, 2, 3, 4. So these are all the possible sets of these. So this is the power set of this. Yeah. So you want to just
Some more are possible, like 2, 3, 2, 4.
oh yeah. So
Like 2 to the power of 4. Totally 16 will come, no?
yes, exactly. So okay,
Yeah, yeah.
yes.
2,
So
3, 2, 4
yes.
will
So
come. 3, 4 will
these will
never
be,
come.
yes. You are right. So 2 3 2 4 and 3 4. So length 1, length 2, length 3, uh, 2 3 4. So these are the different possible combinations. Okay, so this is our power set basically. Let's comment it out. So how can we write a recursive function to print this power set? Okay, let's so think about it for a couple of minutes. So in all the problems we solved last week and also the last problem that we solved, we had to call our function just like we call our function just once, but here we have to kind of call it more than one time for the remaining problems. So let's just start solving. Let's call it p set for power set, and let's take a set s. Okay, and yeah, we'll do something and we'll return we'll not return, let's say we'll just print some stuff, and we'll have an input. So s equals to say 1 2 3, and then we'll call p set on this, p set s. Okay, I think this should be the driver code. Okay, so now you have to do something to print the set, right? So here we also have to keep track of another thing, which is like so the basic method here which we want to follow is we want to take one character or say one element from this set, and then we want to basically we want to take it into the subset, or we want to not take it into the subset, and we will already have a current subset, and for each current subset we want to add the current number to the list to this current subset, or we don't want to add to the current subset. So what do I mean by this? Let's start coding and we'll understand what we are trying to say. So let's say current set is by default it is set, so it's an empty set by default. So in the beginning we'll start with the empty set as current, because till now we have not looked at any numbers in the set till now. So let's take so first we want to extract out one number from the set, so we can do something like this. We need to convert a set to a list before indexing. So from a set you cannot directly extract out a number, so you need to convert the set to a list and then take out one element from that. Okay, so I think this is it. Okay, yes, so we have taken, okay, let's start with the base case. So base case, I think you can again understand if the set is empty. So if not s, so this means that if the set is empty, then we don't print anything basically. So print empty, or we can just return. So return just means do nothing and return. Okay, but if it is not empty, then what do we want to do? We want to take the first element from the set, and then we want to let us print this element along with the current set. So let's say, so the current set union. So if you know the union of sets, it goes like this. We can do something like this. So not s, sorry, let's call it number and number. Okay, so this is basically the union of the current set and this this number. So basically we are adding this current number to the already subset that we have worked with. So initially this will just amount to just the single numbers, and then we want to call this function again, but we want to call it 2 times. So we already have a current set, so now we want to include this number in the current set and print out all the different possible combinations, and then we don't want to include this number in the current set, and we want to see what are the possible combinations with. So we basically want to create all possible combinations with or without this current number, right? So we want to first say call pset with so we can just do this something like this. I hope this will work, otherwise we need to convert it. So we want to call both sets. We want to call this function 2 times. So each time we are removing this number from the set itself, but so we in one case we are adding this number to the current set, and in one case we are not adding this number to the current set. So that is what we want to see. So say we want to just call it with the current set itself, so we are not adding the current number to this current subset. And then another is when we are adding, so we just do union again, num. I think this should work, and let's see what it prints. So this is our code. Let's see what it prints. Oh yeah, so it does not work like that, so you need to convert it to a set. Yeah, so can we do a set number? I don't think so. No, we need to do a list like this. Okay, let's do it like this. So here basically what we are doing is just the same thing, just we converted this number into a set. So we created a set of basically just one number, and then we are here also we need to write it, and we are just finding the union, and here we are doing the set difference, basically removing that item from the set. So let's test it now. Okay, so we see that we get some items, not all. Yes. So yeah, so we need to do some changes over here. Let's see. I was not expecting this, but okay. 1 2 3 1 2 3. Okay. Yeah, so here basically we are taking just one element, but we need to I think okay, let's try to debug. If anyone has any ideas here, feel free to contribute.
Is there no else condition here? Just you have put if not else.
Yeah, so this basically everything else is the else condition, because here we are returning one item. So if we are returning, that means that we are going out of the function, and if this if statement is not true, then we are basically just going into the else part. So this we can write this part in a else, this whole thing in a else, but it's the same thing. If we write this or if we do this is basically the same thing, because if it is becoming like if it is an empty set, then we are just returning from this function, and if not, then we are going into the rest of the function. Okay, so I think what we need to do is we can't just take the first element. We need to do it for actually all the elements, I think. So let's try that for number in list S. So let's try this. So now what we are doing is we are not just calling this function for just the first element. We are calling it for all the elements in the list basically. So let's see what does this do. Yes, so now we have a lot more. Let's start with us. Yeah, now we have too many more people. So I think we need to yes, let's do this printing outside. I think we should print it outside. Let's see. Here also there are some extra sets. 1 2 3 4. Where is 1 2 3 4?
The very first time which you run gave a correct answer. Can you just press Ctrl Z few times? The first time when you run it, no, it came correct answer.
No, this is not the power
In the
set.
console, yeah, that is correct answer, no?
Oh,
The
this was
first
the
time.
correct answer.
Yeah, that is a correct answer because it is only 3 elements, 2 power 3.
Oh wow. Yeah, actually it was correct then. Sorry, my bad. Yeah, I got confused a bit, but okay, so it was correct apparently. Yes, so okay, sorry for the confusion, but yeah, this was correct apparently. So let's try it with 4. Yes, so it's working. Yeah, thank you. Sorry for the confusion. So yeah, so we don't need to run a loop. We just follow the initial whatever we did. So we just yeah, we print it, and then we print this number. We extract out a number. We print it with the current set, and then we call the the function two times. Once we include the current number, and once we don't include the current number. Okay. Yeah, sorry about the confusion. So the original code was correct. Okay, any questions? Okay, no questions. Then let's move on to the next question. Okay, so this is a very popular problem in recursion, and which is called the Tower of Hanoi. So basically, I'll explain what is the problem, and this might seem familiar to some people. This is something that kids do when they're like very small. So the problem is just to write a recursive function to print the steps for the Tower of Hanoi for say 3 towers and n disks. So here, for example, so the problem is that we have say 3 disks, say A, B, C, right? Or we can call them say 1, 2, 3, whatever. So we have 3 towers, you can say, and we have say n disks. So these are the disks, and here n is 5. So we have 5 disks here, and they're like labeled in. So like the topmost one is the smallest, 1 is the smallest, 2 is slightly bigger, 3, and so on. So the objective of this game is to bring all of these disks from say A to C. So we have to take all of these and bring it in the same manner into C. But the only rule is that you can only pick up one disk at a time from the top. So you can only pick one from the top. You cannot pick say 3. So you can pick only one at a time from the top, and you cannot place a larger disk over a smaller disk. So you cannot place say 2 over 1. You cannot place say 3 over 1. But you can place 1 over 3 obviously. So here you can see we have placed 1 over 2, 2 over 3. You can place 1 over 3, but you cannot place 3 over 1. So that is the rule. So I'll also show you a solution. Let's so yeah. So here you can just if you search on Google Tower of Hanoi, then you will get something like this, where you can actually play and try to solve it yourself. So we'll solve it for say 3 and 4, and then we'll try to understand what is the logic behind how do we actually solve it, right? So here we have say only 3 disks at a time. So we want to move them all to the tower 3. So what we can do is we can move this here. We can move the second disk here. We are moving the first disk here, and now we are doing it here. We are moving it. We are moving it here, and now we are moving it here. So that's done. Okay, well done. Yay. Okay. Okay, so we did. Obviously, you can do it. If you do some mistake, you can like go back and do corrections. But it says in the bottom that minimum moves is 7, and we did it in 7 moves only. So we want to do it in obviously the minimum number of moves as possible. So let's do it with 4 disks and try to see the pattern if you can. So now let's move it to say here, and then we move this here. We move it here, 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 here. Take this here, the bigger one. Let's bring it here, and then let me think. Yeah, here, here. Bring this here, this here. Yes. So again we did in 15 moves. So I followed. So you understood that in between I was thinking a bit. So obviously there is a algorithm, a method that I am following to reach the minimum number of moves. And if you have thought about it, can anyone say what is the logic behind? So if you see with 3, it is really easy to understand. So anyone has any ideas about how to solve it? So if you already know some programming languages, you may already know. You may have already solved this in other languages. Can anyone tell how to do this? Yeah, I think it will be easier to unmute yourself and tell instead of writing in the chat. Okay, so everyone is.
Let us consider top two things as one single entity,
Uh,
and then it will become like only two disks.
yes, you're.
Assume top two as one single entity, then it will become only two disks, and then
Yes, you're on the right track. You are on the right track. Yes. So what we want to do is basically, so the algorithm is like this, that so however disks you have, however many disks you have, so say you have n disks. So what you want to do is you want to move n minus 1 disks to the other peg, the other tower. So you want to move n minus 1 disks to say tower number 2 or tower B. Then you want to move the last disk to the tower number C, and then again you move the n minus 1 disks to the destination. So what we are doing, so I'll just show you what I mean to say. So so this was my first initial steps, right? So what we basically have done here is, so we have 3 disks. So what we have done, we have taken 2 disks and brought them up to the intermediate tower, like tower B. Then we move the larger disk, the last disk, to the destination. So our destination is tower 3, and then we again take these two disks to this tower. So obviously we cannot take them together, so we apply the algorithm again recursively. So what we do, so we want to move these 2 disks to this tower, right? So what we do is we take all the n minus 1 disks to the other tower. So here only there is only one, so we take all the n minus 1. So we take all the n minus 1 to the other intermediate tower, then we move the largest disk to the destination, and then we again take all the remaining disks to the previous. So again let's try it with 4 ones, then it will be very clear. So what we want to do is, again sorry for that. So okay, so we want to, here we have 4 disks, so we want to move the top 3 disks to tower B, which is the intermediate tower. Then we want to move the disk number 4, the largest disk, to tower number C, which is the destination tower. And then we want to move the top 3 disks, the n minus 1 disks, from the intermediate tower to the destination tower. So again for 3 disks we have to again think about one level up in recursion. We have to think, so we want to move these 3 disks to this tower, right? So what do we want to do? So we then have to move the top 2 disks to this tower, okay, and so on it goes. So we want to move the top 2 disks to the tower number C, so we want to move this disk to tower number B. So it goes like zigzag way. You have to think in a recursive way. So you want to move this here, and then we bring this here. So again we want to move these 2 disks here. So we want to take the n minus 1 disk, move it to the intermediate tower. We want to take this disk and put it to the destination tower, and then this from the intermediate to the destination. Again now we come back one level up in the recursion, and we move we move this to tower C, and then we repeat again. Let's keep going from here. So I think you get some idea of how it's working, right? So let's try to code it out. So believe me or not, so this is very easy to code out in recursion. So this is actually one of those problems that is not so easy and straightforward if you are trying to use loops. So if you try to use loops, it will be very lengthy. You can obviously do it with anything, with loops or without loops, with recursion. But this is one of those problems that if you try to do with loops, it will be very difficult to understand, quite long. But if you are doing it with recursion, then it is quite simple, because you can see the problem by default, the problem has a recursive nature, right? So that is what we want to solve here. So let's define tower of Hanoi, TOH, let's tower of Hanoi, and we want to say give the number of disks, and we want to say what is the starting disk, say source disk, or say let's say disk source, sorry, tower source, and the destination tower, and what is the intermediate tower, right? Tower inter. Okay, we have 3 towers. So what is the source tower? Say 1, 2, 3. what is the destination tower, say 1 2 3, and what is the intermediate tower, 1 2 3. We want to do something. Let's prepare the driver code. So let's say we want to move disks, 4 disks from say tower 1 to tower 2. So we'll just call say TOH, say 5 so let's start with 4 disks, and then we want to move it, so let's start with 3 disks, and we want to move it from say tower number 1 to tower number 3, and we want to use tower number 2 as intermediate. Let's just keep it 4 to keep it simple. Okay, so just try to understand what are these numbers. So 4 disks, we want to move 4 disks from tower number 1 to tower number 3 using tower number 2 as intermediate, right? So you can also change these numbers, it won't matter too much. So the recursion goes, we'll try to think now recursively. Obviously, the base case, if we have only one disk, so if n disks equals to 1, so you can assume there will be at least one disk. If it is less than one disk, then there is nothing to move, so nothing to do basically. So if there is one disk and we want to move it from source to destination, so what do we want to do is basically we can just move it from the source to the destination, right? We don't have to think about anything else because there is only one disk. So we can just print out, say print something like say move disk. So this is how you can do percentage, or let's just do it simple way. Move disk plus number string n disks. So we are moving the top disk, and let's say just we can keep a counter, but let's just do like this. Move top disk from say str t source plus 2. Let's just do a break here. 2 str t dust. Okay, so move top disk from this tower source to tower destination. Okay, so that's what we are printing. And so if there are more number of disks, so we are following the same logic as before, like I said. So if there are more than one disk, then we want to move the n-1 disks to the intermediate tower, then move the bottommost disk to the destination, and then move the all the n-1 disks from the intermediate tower to the destination tower. So we want to print basically 3 lines basically. So first we obviously first we move let's comment it out for now. So first we want to move say n-1 disks from the source to the intermediate, right? So we'll just call tower of Hanoi again, n disks -1. So we are reducing the one disk, sorry, and we want to move from tower source to tower intermediate. So we want to move it from the source to the intermediate tower, and we want to use the destination tower as the intermediate, right? So try to understand what is going on here. This might seem a bit confusing, but so originally you can see we want to the order of the parameters is source, destination, and intermediate, right? So we want to move n disks -1. We want to move it from the source to the intermediate tower using the destination tower as the intermediate tower. Okay, and then we just print out that move top disk from source to destination as it was, because we have only like one disk remaining now. And then we again want to basically move all of the, so we already have moved n disks from n-1 disks from the source to the intermediate. Now we want to move it from the intermediate to the destination tower, and we want to use the source tower as the intermediate basically. So this is basically just the code. just a few lines. So yeah, let's run it and see what output we are getting. So let's try it with, say, just 2 disks at once. Oh, so we have some errors apparently, sadly. What is the error? Maximum recursion disks. What is n disks? 1 minus 1. Okay. Okay, so sorry, here we have to return. Forgot to give return over here. Okay. So if there is only one disk, then we want to print and we want to return. We don't want to call it again. Okay. So let's run it now. Okay. So we have only 2 disks. So you can see that move top disk from 1 to 2, move top disk from 1 to 3, move top disk from 2 to 3. So let's try it with 3 and then let's do it in the simulator game side by side. So this is for 3 disks. So let's try to see if it is correct. We'll just do it quickly. Let's put it to the side. So move top disk from 1 to 3, move this from 1 to 3, then move top disk from 1 to 2. So 1 to 2 top disk, then move top disk from 3 to 2, 3 to 2, then move top disk from 1 to 3, 1 to 3, then 2 to 1, 2 to 1, then 2 to 3, and then finally 1 to 3. So yeah, so we can see that our code is correct. Okay, so now this is okay. Any questions about this? So it is a bit difficult to visualize from here, but any doubts, any questions? Okay, so let's move a bit quickly because time is less. So I have actually written a code to actually print this so that you can visualize it well. So I am not going to explain this code exactly what it's doing, and you can actually write it yourself. It's not a very difficult code to write. So to print actually the towers and the disks, so you can actually take a screenshot and you can go through this code, or yeah, you can try to, like, I would recommend that you try to solve it yourself because it is not that difficult. Just will take some time to, yeah. So what it does is basically I think it takes from 1 to 3, or basically no, it goes from 0 to, okay, so it takes the tower numbers at 0, 1, 2. Okay, let's just do 0 to 1. Okay, and so here what we have here, I have written like some init function, so to initialize the board, like they initialize the disks and move the top disk from like start tower to the destination tower, and then display the board basically. So this is only the main function which like displays the board. And so okay, so what we have to do over here is just instead of print, we have to call that move function and we have to like display the board. So let's just do that. So okay, initially we need to init board goes to init. We can add a board over here. So that is nothing to do with the recursion itself, but that is just the board that we want to print. So we'll just pass it here. So what we want to do here is basically we want to move top disk from source to destination, right? So here we are going to do the same thing, move. So we are moving in the board, we are moving from T source to T destination, right? And then we are displaying display board display, right? And here also we'll do the same, just do this, and that's it. So let's now see how it looks. Let's start with, say, I think 5 and disks. Let's do 5 and disks and disks. Okay. Oh, tower of an oh sorry. Okay, yeah, here we have to add the board because we added about one parameter, so we are just adding the board here. And now let's see, should work. Okay, it's working. You can see I gave a delay, so you can see it's moving one by one. It's a bit, yeah, it's a bit buggy on this console, but you can see it's moving one by one. Yeah, it's a bit buggy, so but yeah, you can write this display function yourself. And to clear the screen, actually you can use this os.system clear if you are on, say, Linux or Mac, and if you are on Windows, then use os.system cls, so that will just clear the screen. And so yeah, it's going one by one. Yeah, so they take this as a, you can, homework. You can try to build something like this yourself, and like, yeah, you can see that it is, yeah, looks cool. And yeah, to like do the pause, you have to do like time.sleep, and then you have to specify how many seconds. Like I have given 2 seconds sleeping between each action, basically. So yeah, it's done finally. Yay. So yeah, that's how it goes. Okay, so I guess no questions. Okay, time is less. Let's solve one more question. Okay, let me check the chat once. Okay, no questions in the chat. Okay, then let's do one more question. So this is write a recursive function to solve the subset sum problem. So this is a very like standard problem. If you Google subset sum problem, you'll get many answers to it. And actually, for this problem, believe it or not, like using a recursive function is very inefficient, or you can say it will take very long. And people don't use recursive function to do this, because it will if you do this, if you try to solve this problem with a very large input, if you use a very large large subset, then it will take a very long time. But yeah, for our purposes, this is a very good problem to actually do it using recursion. Okay, so what is the problem? Let's see. So a subset sum problem states that so you are given a set of numbers, say set S, and a number n. So you are given two inputs, a set and a number, and you have to find, is there a subset of S whose sum is equal to n, right? So you have to find out if there exists any subset of S, if it is if you sum up the numbers, if you get this number n. So there are some variations of this problem. So there is one thing called say maximum product of subset sum. So that is like so you have to find the subset whose product is the maximum. That is another variation. But here we just want to see if there exists a subset of S whose sum is equal to n, right? So this is a very standard problem. If you Google, you will get a lot of simple as well as complicated answers. But here also, as you can understand, here also we have to do something along the lines of like we did power set. So here also we have to kind of like iterate over all the, not iterate, you can say like, yeah, like go over all the different possible subsets of S, and then we have to see if the sum is equal to this number n, right? So let's write a recursive formula. Okay, subset sum problem. So here we have some subset sum, let's call it that. So we have the parameters will be a set S obviously, and a number n, which is like the sum. We'll do something, and this will return either true or false. Okay, let's initialize the set, say 1 2 3 4 5. Let's just take a list for simplicity purpose. You can also take a set. We just have to do those set things. So let's just take a list as a set, and let's take a sum as, say, n equals to I don't know, let's say 2 plus 3 plus 4 is like, say 9. Okay, so 9 is a number that exists here, but 8 is, I think, no, 8 also exists. Let's just remove yeah, let's just keep it like this. So we have a set, we have a number n, and we want to see say if subset sum S n, then we need to print there exists a subset with sum equal to say equal to n, or whatever you want to write, and else print, let's just print there exists no subsets and something like that. Okay, so now we come to the main problem. So how do we actually, what is the recursion that you have to see, right? What is the recursive case that you can see? So here also you can kind of understand the base cases. So here there will be more than one base case. So you have two variables here, both are changing, you can say. So one base case you can think of is if the set is empty, right? Okay, no, that comes later on. So say, let's say n is 0, if n equals to 0. So what this means that you want to, the problem basically becomes, is there a subset whose sum is 0? So obviously like a null set, if you don't take any elements from the set, a null set is obviously a subset of S and its sum will always be 0. So we know that there will always be a subset of any set whose sum is 0, right? So we can just return true. Base cases, and if n is not true, then we have another base case. So let's say S is empty, if the set is empty, if not S. Here also we can write it something like if not n, just fancy way of writing. So if we know that, so now we know that the sum is not 0, we want a non-zero sum, and but the set is empty, right? So if the set is empty, we don't have any subset, basically we cannot add up numbers, so it will obviously be false, return false. So why is this? Okay, so these are our two base cases. So any doubt on these two base cases, why we have these? I think these should be pretty straightforward for now. So if the sum is, we have to sum up to 0, then we obviously have the null set, so in all cases it will be true. And if it is a non-negative sum but the set is 0, set is empty, then we cannot ever sum up to reach that number, so it will obviously be false. And yeah, so you can also set another base case, like something like if sum of all the numbers in S is less than n, then also return false. You can do something like that also, but that is not necessary. So something like if all the elements you sum up, say if I call it, so I think the sum of all these numbers is 15. So if I call it with something like 20, then obviously we cannot find any subsets that add up to that number. What was it? Let's say 7 again. Okay. So but we don't need to write it. Okay. So now what is the recursive case? So the recursive case will be, you have to understand what we need, how is the repeating pattern. You have to understand the repeating pattern basically. So we can obviously take one element from the set, and so to form subsets, so we have to consider each element. We can consider the first element, say item equals to S0. So now we have to check, so we have to find a subset whose sum is equals to n, right? So we can do two things again, similar to the power set. So we can either include this item in the subset, or we can not include this item in the subset, right? And we have to check both conditions. So it might be the case that if we include it in the subset, then we may get some subset whose sum is equal to n, or it might be the other case also, that if we include this item, then we may not get the final subset, right? So we have to check both ways, if we include this item in the final subset, or if we don't include this item in this final subset. We have to check both conditions, right? So this is actually, I think, even easier than, once you understand the problem, it's easier than finding the power set. So we have two cases, right? So include this item. So if we include this item in the subset, we then just say S. So we remove this number from the, since we have already considered this number, so we remove this item from the original set, and we have included it in the subset that we want to finally check, right? So we can just say we have reduced the sum by this number, n minus item, right? So basically, if we include this item in the subset, then we are left with so we want to find another subset basically which has basically n minus this number. So this is the new sum that we want to achieve basically, because we have already taken this item, so we all subtract this number from the final sum that we want to achieve. And the other thing is, obviously, let's copy paste. If we don't include this item, then we obviously remove this item from the original set, since we have already considered this. But what we do is we don't reduce the sum, because we have not included it in the subset. So we just keep the sum as it is. The sum has not changed at all. Okay, it's called subset sum. Okay, subset sum. Okay. Yeah, I think that's it. Yes. So it's that simple. So once you obviously get the idea, it's that simple. Okay, one condition you have to check is if adding this item. So like I said a while ago, so if sum of the all items is less than n, then you cannot obviously find any subset. So here we have to do that check actually, that if this item is actually greater than the sum, then obviously we cannot include this item in the subset, because then the sum will go beyond the number n, right? So if item is less than equals to n, then only we do this part, which is we include this item in the subset and we reduce the sum by this number. And if it is greater than or less than, we don't care. We will always try the possible combinations where we don't include this item in the subset, right? So let's run it and see if our code is correct. So there exists a subset with sum equal to 7. So this was our subset. So suppose we remove some numbers such that, suppose we give just some other numbers, just some 8, something like this. So here we can see we don't have a subset which equals to 7. I hope there is not. So there, so it gives some error. Okay, let's try to. Okay, so here it should be returned true. This will be okay. So what we have to do is basically, so this was returned true. So this is actually wrong. So what we have to do is basically, we just need to find one particular subset. We don't need to find all of the subsets. So we need to see if either of these combinations are amounting to true. So let's call it say result. Let's do this. Let's invoke this first. Just the same thing, just ordering is different, and let's save it inside the result. Okay, result. So we are getting the result from this, and what we want to do is basically take the result, result, and we want to find the OR of it, because if any of these results are like true, if we can find a possible subset from any of these recursive calls, then only we have the correct answer. So what we want to do is find the OR of this. So we want to do res equals to res OR. So if this is true, then also we can just say that yes, there exists a subset, or if this is true, then also we can say that there exists a subset. So you want to just do the OR of these two results, and then we finally can return the result. Okay, so now let's see. Now it should be correct. So yes, so there exists no subset, and if we do again, let's check the something like this. So I think 5 and 2 will be a subset. So yes, so there exists a subset with sum equals to 7. Okay, so this is our subset sum problem. So obviously here we are not actually finding out the final subset. That you can do with a small little bit of changes. You have to add some more parameters here, like the power set problem, like we printed out the power sets. So like that problem here also, you can actually print out what is the subset that is equal to 7. You can try that out as a homework, I think. But yeah, so any questions about this problem? Let me check the chat. Okay, no questions in the chat. Okay, any other questions about any other problems? Otherwise we can end the class. Okay then. Okay then, if there are no more questions, then I'll stop presenting. Okay, then I'll stop the recording, and